So the router interface connected to the VLAN trunk is actually divided into sub-interfaces for each VLAN. We're going to see how each VLAN is split up with subnets and their own default gateways as we look at the configurations. So here's a look at how Gigabit Ethernet 00 interface right here is connected to the switch right? So this switch is connected to this interface here on the router, and this router interface is split up. This one interface that this cable line is connected to is split up into 3 sub interfaces: 0.1, 0.2, and 0.3. So this sub interfacing can only be done on routers, right? So this top sub interface is 0.1, and this is used for VLAN 1. This encapsulation .1q native command means that this interface is assigned VLAN 1. Native here means that if any traffic comes in without a VLAN tag, it will automatically be given VLAN 1. Next, we have to assign the IP address and subnet mask to the sub interface. This IP address will be the default gateway for any host devices in the 192.168.1.0 subnet. 0 being the subnet, the IP network address. So now that we have the configuration for VLAN 1, we can fill in our VLAN chart above. So we have the subnet. So 192.168.1.0/24/24. We can tell from this here, 255.255.255. That's 24 bits turned on for the mask. That's why we got /24. And using this /24, we figure out that 192.168.1.0, which would be the first available address, is the network address, and that's how we get the network there. Default gateway is what we attached here, 192.168.1.1. So now that we know the information here, let's move on to VLAN 2's configuration. So 0.2, sub interface 0.2. Encapsulation .1q2 means that this is designated for VLAN 2, right? And then same thing here, we set up the default gateway address that's going to be assigned to VLAN 2 for anything that's in the subnetwork 192.168.2.0/24. And then same concept for the third one, right? VLAN 3, 0.3 for the sub interface. .1q3 means VLAN 3. And then we have the default gateway address here and the subnet mask. Here's the network. So using the sub interface, trunks, VLANs, and subnetworks, let's lease out IPs based on what VLAN a device is attached to on a switch. So here's the setting for the router interface that is assigned as a trunk, which we use to fill out our VLAN subnet default gateway chart up here. Now let's look at the settings the router has that makes the router a DHCP router. So this is a DHCP configuration. So this IP DHCP pool command creates a pool that will contain a bunch of IPs that can be used. Here we named the pool VLAN 1 pool, right? So this is creating the pool with the name VLAN 1 pool. Here we're telling the pool we created what network of IPs to use by writing in the network IP and a subnet, right? Network IP, subnet. Finally, we have to place in what the default gateway will be for this pool of IPs. And this is going to be matching what we have here on the sub interface. Because this sub interface is what we're going to use as the default gateway for anything that's in this network. So anything in VLAN 1 is going to be assigned 192.168.1.1 as the default gateway. So when anything in VLAN 1 wants to talk to VLAN 2 or 3 or anything else that's outside of its network, it's going to send the data to this subinterface where the router will do its job. Notice that the same pattern works for VLAN 2 and the VLAN 2 pool that we created, VLAN 3 and a VLAN 3 pool. You have the default router, default gateway, and the subinterface IPs. So let's look at this network again, this time seeing how a device attached to a VLAN 1 switch port will get a VLAN 1 IP, right, from the router. So the first step is the laptop PC in VLAN 1 when attached to the VLAN 1 switch port with the IP settings set to DHCP, right? So in the IP configuration settings, you make sure it's set to DHCP. Then what it's going to do is it's going to send a request for an IP DHCP server known as DHCP Discover to everyone in its own VLAN. The DHCP Discover request will travel up the switch trunks into the router. The router will then see that the DHCP Discover is tagged as VLAN 1. The router, as a DHCP server, will see that the data is being received on its sub interface for VLAN 1. Right? The router then looks at the DHCP pool with default gateway for VLAN 1, so knows which pool is assigned to VLAN 1. The router then determines an IP from the pool to send back to the PC. The router then sends a DHCP offer data response to the PC with an IP lease from the pool and with the default gateway information. Once the PC gets a response, the PC will send back a DHCP request packet, data packet to the server. In this case, the server being the router, the DHCP server, and it's going to request to reserve that offered IP. To end the conversation between the router and PC, the router will send back a DHCP acknowledge packet, letting the PC know that the IP has been reserved and everything's all good. So, to recap, the host device that wants an IP, in this case the laptop, sends a DHCP Discover to everyone in its subnet. The DHCP server, in this case being the router, gets the DHCP Discover data, finds out which pool of IPs to use, and sends a DHCP offer of an IP lease back to the laptop. The laptop receives a DHCP offer and then agrees and sends a DHCP request to request the server to reserve that IP so no one else can get it. Finally, the DHCP server agrees and sends back a DHCP acknowledge to the host device being the laptop in this case, letting it know that everything's all good. The IP has been reserved. No one else can use that IP except for that laptop. Now that we got a glimpse of the router, let's look at the router commands. Routers, like switches, have 3 access levels, each with different commands that can be found by typing in the question mark at that level. Like the switch, the first access level is the user exec mode, which is the initial startup mode. The second access level, like the switch, is privilege exec mode, which is like the admin mode of the router. And again, like the switch, the third access level is global configuration mode. Then we have sub-configuration modes, like the interface configuration mode, the line console configuration mode. And lastly, and here's the difference from the router and the switch, from the router and its access levels and the switch and its access levels, is we have the router engine configuration mode, which is used to modify settings for routing protocols like BGP or OSPF. So notice for the router engine configuration mode, you have config-router after you type in router in whatever protocol you want to configure.